Hello, thank you. I just want to do a quick survey before we actually start. So, can you raise your hand if you've got an Android phone or you use an Android phone? Who uses an iOS device? Oh wow, really? Everyone said, oh, we've got lots of people who use Android here. That's cool, that's fine. So I think actually that's a good point. Is one of the things that we've been trying to get across with all of this is that we think we've got a good model for how you build the next generation web applications with progressive web apps. But it's not all about the technologies. It's just about how you think about you're building these applications, whether it's the app shell and you're kind of loading content dynamically, or whether you're using Service Worker to help you make your applications work offline. So we think we've got a good model. These applications they work on iOS. They work on every single different browser that's out there if you build them correctly. If you don't build them correctly, then, well, you've made a mistake. So I just want to kind of start off now. So this talk is about the future of the web, and I've got a couple of demos that I want to show you. But the most important thing, and I wanted to kind of talk about this as well at the start, was you've seen a lot of things about Service Worker today, and everyone's been talking about Service Worker. But one of the really good things is that it's actually been kind of started to be developed here in South Korea as well. So we've got multiple browser vendors, multiple handset manufacturers building applications and building the browser infrastructure that actually makes kind of Service Worker impossible. So it's not a Google thing, it's not a Chrome thing, it's a web thing, and other browsers are starting to adopt this. So one of the things I wanted to say is Junki Song. I did see him a second ago or earlier on today. I don't know where he is. Can you raise your hand? No. Oh, hey, there you are. Sorry, I did see you a second ago when I was looking at you. So he's been helping out with the specification and getting to the Safari browsers to actually support these APIs. So this is a really great story, right? We can build compelling applications on the web. And we've seen that today I hope we've seen that today at least with progressive web applications. But when we think about going forwards in the future, I do like to think about the past. And I look at this as the first ever native application, right? It's the difference engine, 1822. Charles Babbage designed this. He never actually built it. But I think it was Oxford University. They went through his designs, they built it. They sold it to the Computer History Museum. I don't know whether it's in the Computer History Museum anymore, but it's in It was in Mountain View in California. And the great thing was that 1822, this could basically solve and factor polynomials. It was a one-function application. So if you wanted it to do something else, you had to go and build another 3-ton machine and then kind of ship that around to actually be able to do any more functionality or create any more functionality. But the interesting thing is that Charles Babbage in 1822, he said, this is really cool, it's great, and I know I can build this and it's going to solve a lot of problems, but we want to put programs on it. We want to be able to program it so that it can solve multiple different types of problems. So he designed another engine. This one's called the analytical machine. Again, he didn't build it. He didn't actually build any things in his life. He designed a lot of things. But his son, Henry Babbage, tried to build it, and this is actually one of the actual machines in this British Science Museum, I think. Now, this kind of came with programmable cards, on wood. They punched holes into wood and kind of pushed it through. It was a really interesting experience. It didn't work. It couldn't add up properly. It got off by 1 errors quite frequently. But I think it's kind of interesting because even kind of in the late 1800s, they were thinking, we know that computers can help us, and we need to program them, and they're going to kind of revolutionize our lives. If you jump forward, a long time forward into the 60s to the mid-80s, we had these machines, these massive machines that you could program, and you had to go up to them with punch cards. So it's not too different from the analytical engine. You'd go up to it with a punch card, put it in, and then maybe a couple of days later, you'll get your results back. Which is interesting, really, because we've got programmable machines now which allow us to do massive amounts of calculations and tabulate data and a whole lot of other things. But it's still slow, right? 2-3 days just to get some basic results back. But it's an order of magnitude difference from whatever we've had before. And then this is coming into my own era. I don't know how many of you had Commodore 64s, but I had a Commodore 64. I actually had about 30 Commodore 64s because my father used to fix Commodores and computers. And when they were broke and people didn't want to pay him, he just kept the machine. So he basically just joined all the components together and made a whole bunch of Commodore 64s. So the interesting thing about this is that through cassette tapes, you could kind of deliver applications over the post, over kind of in shops and a whole bunch of other stuff. But we could actually deliver games, apps to your local machine, right? That was actually really cool, quite powerful. If you're in America, obviously the Apple II is another kind of concept. Now, interestingly, around about the same time, the 5.25-inch disk drive came out. And for me, I remember, my dad also fixed computers. I think he also copied a lot of games and pirated a lot of things as well. I don't think I ever paid for a game. But this was an interesting thing because it was a 5.25-inch disk drive. I seem to remember it loading games and programs in about 5 seconds. I think it was a bit longer. But like the idea was you put it in, you press run, or you type in run, and then like 10 seconds later you're playing the game. And like the usage of the computer, my usage of the computer changed drastically. And I thought that was quite powerful. And then obviously if you've ever installed Windows 95 or Office 2000 and you didn't have CDs, like the 3.5-inch floppy disk drive, that also changed the way that we use computers. You could save data, transport it in between machines quite easily, and all that type of stuff. It was a pain if you had to reinstall Windows 95 because there was like 27 disks, and it took about 6 hours to install. But you could actually deliver a full operating system with this. It was pretty good. And then obviously, like we knew there was problems there. We couldn't store a lot of data. CDs, DVDs came out. So we can like transport huge amounts of data around and be able to write to them and read from them. But that changed again the way that we thought about using computers, right? We could deliver games, like really complex, big games that we've never been able to do before. And just kind of someone picks it up from the store and they go home, they install it on their Windows machine. But if you've ever done anything with Windows, like this was a common thing for you, right? Whether you had to go to your parents' house to fix their computer or your computer, like you would install an application. It wouldn't always work quite well the first time around. It would destroy your computer potentially, overwrite other settings. It was just a nightmare to manage the installation process. And around about the same time, we started getting compelling web applications. And as Robert talked about this in the keynote earlier on, we were kind of getting Ajax-based applications where we didn't have to reload the page to dynamically interact with the applications. The interesting thing about the browser was it was far less capable than the native applications on the operating system. We didn't have Microsoft Office at this time before Google Docs existed. Like we knew the browser was far less capable. It couldn't do as much, but the delivery mechanism was so much better than going into a store and like buying a CD and installing it that way. You just type a URL in and you get straight to the experience, and that was really, really, really powerful. And I think that's where I came into that's how I got into the web development, was because I can distribute my sites, my applications, and my code and sell my businesses at the time, just all on the web. I didn't have to care about going through any kind of stores. It was good. The interesting point is that every single phase of computing, like some form of major friction was removed. Things got a lot easier for users to build interesting applications. And in most cases, it's the delivery method of getting the software. Alex Russell was saying that, who's one of the Chrome engineers that we work with, distribution is the hardest problem in software. And we all know this, right? Like we try and get our apps in the App Store, we try and get them promoted and get users to install them. We're on the web all the time, we have to advertise our services. Like these two, App Store and the web, are actually really good ways to deliver software, far better than we've ever had in the past, but it's still fundamentally pretty hard. And I like to look at this, this is the way I do a breakdown of it. So this is a timeline. Below the dotted line is pre-internet. Above is when the internet came out, and then we had the web. And the web has gone through the before mobile era and the mobile era. We had a bumpy ride at the start of the mobile era. We weren't ready. Developers weren't ready. Users weren't ready to use the web properly. I think we're there now. But the interesting thing is that as people start using their phones more and we kind of find new ways to actually deliver applications, we got app stores, chat clients and a whole bunch of other stuff coming through. I don't know what comes after chat clients, but there are going to be more and more ways that we deliver software on mobile devices. And I actually think the web powers a lot of these experiences, right? A lot of people still build web view-based applications. Most chat applications, their kind of infrastructure is built off the web views themselves as well. So I think it's actually pretty interesting. But the one thing that I want to kind of talk about, and Robert again mentioned this in the keynote, was, and I'm going to read it verbatim, in a consumer mobile app, every step you make a user make a user perform before they get value out of your app will cost you 20% of users. And I think this is really interesting. So I took the stats and the data, and this is all backed by real data. Well, it kind of comes from real data at least anyway. And I tried to chart it out to see what it looks like in a graph. And I was trying to compare web with native experiences. And so it came to this, right? So the orange and blue sections install native apps. This is the worst case native experience. And there's 3 or 4 different steps that you have to take before you even get the user opening your application. You have to send them to the store. You have to get them to actually be convinced to download your application. Then they have to accept the permissions. It's crazy. Then they do the install. They wait for the download. And then you've got to get them to launch the experience. And data has been shown, even on iOS, that this is roughly the curve that you see. You lose 20% of users at every step. The same happens for the web. We're not saying that you don't lose users on the web. But when you look at this, the actual point where you start to lose users is the second that they've had to open up your app. The URL gives you that point of entry into the experience. And then you have to kind of work out how you actually keep the user engaged in your site. So this is the fundamental question, right? This is what Gabor, who actually wrote the original study, said, is like, so what do you do? There's not much you can do until the user gets to the point where they've opened your app. But once a user is signed up, make sure you take them through by hand along the funnel. What he's basically saying there is that user experience is the most important thing. Like, you can't control the app stores, the Android App Store or Android Marketplace or whatever it's called now, Play Store, right? You can't. So I don't like Android apps. No, I do like Android apps, I'm joking. But you can't control any of those experiences. It's completely out of your hand, other than kind of SEO and a bunch of other stuff that you might be able to do. So once they do get your experience, don't lose them. Like, keep them inside your experience and give them good value. And this is where I'm kind of trying to say, the web's and native's battleground is in this space here, right? We think we come in with more users because we don't lose them through all those steps to get the user onto your experience. But we know that's not kind of true, right? We know the battleground's there. We know we need to optimize that experience, but there's a reason why native applications do far better in terms of engagement. And it's this thing, right, where I've tried to chart this down. Is once you've gone through the first couple of steps, users don't keep coming back to your application, right? They don't keep kind of coming back to you, whether it's through the push notifications we saw or the presence on the home screen with add to home screen. Those things that native applications have always had on their platforms, and we've never really had that ability on the web up until now. So this kind of pre-2015, before last year, this is the case. The user will come into your site, and then you'd have to work out ways to keep them re-engaged, email them, and a whole loads of other things. You didn't get into the points where you expected your applications to be, and that's why native applications are a lot better. And one of the other reasons is feature support, and it might be hard to read this, so I'll share the slides out. But I've charted out kind of what features the web has had support for, native style features. So I go from deep linking, which is a URL sharing, to click and install, from geo to camera to push, down to payments. And you can see in 2013, the web definitely was far less capable. Every single browser vendor recognized this. So we knew we need to change. So we started to implement more and more of the features that we thought that the users wanted. And the developers needed as well. And there was a point in about 2014 or 2015 where we did a survey where we asked a whole bunch of developers, what is the number one reason why you build a native application? And the highest answer was push notifications, right? Everyone just said, we want to get users back into our experience. So push notifications is the biggest one. After that, it was offline. They wanted to be on offline support, but they wanted to be on the home screen as well. So when a user has the app installed, they click on the button and load the experience, and it works wherever they are. And as you can see, we've started to solve these. Service Worker originally wasn't designed to do all the things it does with push notifications. It was called Navigation Controller, and it was only designed to make your applications work offline. But then it changed as we realized it could solve more and more use cases, because the Service Worker is designed to live in the background, take up no resources, but then respond to system level events like push notifications and maybe things like geolocation in the future. So I think in summary, really the biggest problem that the web has had is the ability to re-engage with the user. We've not had that way to kind of keep that connection with the user, keep bringing them back into the application. I think that's changed, right? I think we've got multiple ways that we can kind of bring users back in, and we're on a much more level playing ground with how we actually build experiences. And there's less of a clear choice whether you build a native application because you need push notifications, for instance. It's very clear, if you have lots of users come into your experience through the web, and you have a push notification experience on your native application, that's a great way just to say, hey, we just want this on our website, and we can kind of start re-engaging users through that type of experience. The way I like to look at it is this is a marketing thing. If you're in marketing, you probably know these funnels where you have all the users at the start, and then you lose users as you go along through each step. And this kind of highlights where the web historically has been. The web, massive reach, right? We get everyone on the web is able to access our experience. If we build it correctly, it doesn't even matter what browser they're in. They can use our experience, but it's hard to get them to re-engage. Then right at the bottom, we know that we have high engagement and long usage through native applications, But it's actually really hard to get users to do that install, and people are paying lots of money to actually try and get installs onto the native, paying for ads and a whole bunch of other stuff. Like, what is in that middle ground? Like, if we can get that kind of perfect solution that kind of solves most of our needs, then it makes it less clear like whether you choose to do a native application or not. We're never saying never do a native application, because there are still many things that native apps can do that we can't do on the web at the moment, but I think it's changing a bit. So I think that's where we fit progressive web apps. We think progressive web apps kind of fit in there to fill that gap. If your operating system and your browsers support it, which there's a lot of operating systems and browsers that do now, then you can build these experiences that, in theory, delight your users. They work offline, they're installable, they kind of re-engage with push notifications. And then it's up to you whether you decide whether you're going to kind of go that one step further to do apps and a bunch of other stuff. So I think that's interesting. So like the thing that I am going to show demos later on, a little bit later on. I don't know how much time I've got left now, but I think the future of the web is not about APIs. I've talked about some APIs. We've been trying to like level the web up so that it can compete with native applications. But it's not really just about the future, about these new APIs. We don't need to have every single API that native has at the moment, because we have a lot of benefits in the fact that we can just engage with our users a lot more effectively on the first click at least. So I've kind of started to summarize it a little bit. Like multi-device experiences, this is a really hard one for, we've been working on this for like 2 or 3 years. We had this point in time where we knew mobile was massive, but no one was building mobile websites. And when people were building mobile websites, it was a completely separate experience to their desktop site. We want people to build experiences that work everywhere, and in theory are just from one code base. We want people to build faster experiences, and we've got another set of talks which we can do at some other point, and we can share the notes around. But you can leverage things like HTTP2, AMP, and kind of some other models to actually deliver experiences that load like nearly instantly. I know we've got kind of good infrastructure in South Korea, but still fundamentally we want to get experiences that load in under a second. If you integrate a service worker and you do it correctly, you can do 200 millisecond page loads quite effectively and quite easily. Like we can get that fast with our experiences. We need to be HTTPS everywhere. I'm not sure if it was amazingly clear from everything, but service worker only works when you have a HTTPS site. Not the fact that we want you to use service worker, but we think even if you don't use service worker, you should be deploying on HTTPS for every single part of your experience. You don't want people to intercept kind of your traffic. We know that people inject ads, inject content, they can monitor a whole bunch of other stuff that goes on between you and your user. When you don't have control over that connection, you're not in control, I think is the easiest way of saying it. So we want everyone to be HTTPS everywhere, and there are a number of good reasons why, which I'll go into in a minute as well. And we want you to be engaging and reduce friction, like optimize your user experiences. Like you don't have to do push notifications if your application doesn't need push notifications. You might just be able to do add to home screen. You don't have to do add to home screen if you're just like Facebook. Facebook have got push notifications. That's how they get users back in from their web experience. They don't need an ad like an icon on the home screen for them. So one of the things that we want to try and recognize is that we want these experiences to work in every browser, and I said that before. The good news is that we've got a whole number of browsers that actively support. So we've got Chrome, Samsung browser, Opera, and Firefox actively support today the whole the service worker story, which is good. Like some don't support. Like I think Edge doesn't support. Well, sorry, Firefox. So Opera doesn't support push notifications. The rest support push notifications, those type of things. So there are different varying levels of support between each of the browsers, but fundamentally, we have a good section, a cross-section of technology that supports all the APIs that you need to build these applications. We've got Safari. Like Safari doesn't support Service Worker, but that doesn't mean you can't build great experiences that still load quickly. Nice 60 frames a second interactions that we want to expect. It just so happens that it might not work offline, and it might not be as installable to the home screen as you'd expect. And we want these applications to work across multiple devices, right? Like I've seen, like I think Samsung have a VR browser. Is that right? We have a VR. Like we're going to get these points where you're building applications that work pretty much everywhere, right? I'm not saying that we're going to get a browser on your watch, but you could get to the point where you could have experiences that kind of pretty much work everywhere. And you shouldn't be building individual separate experiences for any of those. Like you use responsive design, progressive web apps. You're in a good place to go in that regard. I did actually want to call this out. I don't know if I hope you've all seen it, but there is the developer.samsung.com. It's got a whole bunch of information about the APIs that are supported in the Samsung browser. We've got the same ones on the Chrome side, which I'll talk about a little bit later on. But the one thing I would say is that push notifications, service worker, they're prevalent at the moment, at least in this market, I suppose, which is good. The thing about, like, I'm not going to go into too much depth about the performance side of things, but there are a couple of different technologies or things that you should take away from today. Is that one, AMP is a great way to think about it. So it's accelerated mobile pages. It works really well on desktop. It's just that AMP is a nice word, so they had to put mobile into the middle of it because it would be app otherwise. So the AMP is a great way of kind of getting a user into your site and having the site load within sub-second kind of page load times. And the reason why it does that is because it's a very constrained set of HTML. You can't inject your own JavaScript, which you might think is a problem, but if you're just mainly a content site, it's actually it's a beneficial thing to you because you want users into your experience and reading things properly, and then you get kind of embedded in search and a whole bunch of other stuff. But the thing about AMP is that once the user's in, you kind of want to try and then upgrade them into the progressive web app story, right? So if they're like, you get them in quickly, engage in your experience, and then you want to keep them there and kind of re-engage and kind of coming back that way. So you can use the kind of the progressive web app model of building your applications to then kind of keep the user coming back. It works quite well. One of the things that I think everyone should take note of though is like we've got progressive web apps as a methodology rather than a set of APIs. Rail is another one. It's response, animation, idle, and load. There are different ways that you can think about how users interact with your system. So load, you want a website to load within a second. Idle, you want your website to be able to kind of like respond to the user from kind of an idle state within 50 milliseconds. Animation, you want every experience to run at 60 frames a second so it doesn't feel janky like old websites. And R is response, so you want to be able to scroll, and a whole bunch of other stuff around like 60 frames a second. So there's a whole bunch of different methodologies, but it's just a nice way to kind of like get your head around like what you need to be aiming for every single step of the phase. I look at that as it's a nice model. Technically, it's actually quite hard to get 60 frames a second experiences, but you can do it, and we can share some resources after this conference at least. Move to HTTPS is critical. Like this is the future of the web is going to be on HTTPS. Like if you're on a HTTP site, you're going to lose functionality over time. We've already deprecated geolocation. So if you have any users on desktop or mobile on Chrome, in Chrome 50, you won't be able to use the geolocation API. Like it just won't work. If you're on a HTTP site, you have to be on a HTTPS site. So like use whatever the stuff that Robert said in the keynote, like let's encrypt if you need some free certificates. But you do need to actively move through. And we're going to start pulling more and more of those kind of I think critical function, not critical functionality, but it's user-sensitive functionality because we don't want sites to be able to intercept and then kind of inject like geolocation in and a whole bunch of other stuff, which they can do if you haven't got a secure channel. So it is important. It is very important to do. This list is going to expand even further and further over time. So one of the things I want to talk about the engagement side of things, I'm going to rattle through this pretty quickly, is that if you follow the progressive web app model, we have seen sites that have got increased levels of engagement. And I know Robert said this earlier on, but like Flipkart have seen massive increase in time spent on site, by following the Flipkart model. They've seen a spike in engagement, and so people coming back to their site, it's 40% week on week keep coming back, not just 40% overall. And by the fact that they've got presence on the home screen, the users that use that experience on the home screen, like they launch from the home screen, they basically convert 70% more. They convert 70% better. So, but just by having the icon on the home screen, they're nearly doubling those conversions, at least on that side of things. Which I think for them that's a pretty valuable way of saying, we know that app users, when they installed it and were more valuable, those users are the same users. They didn't have to go through the app install hurdle, but they're still on the home screen and they can look and launch like an application. And I think for me, kind of wrapping this a little bit up, is a service worker is the glue that binds all this together. And I don't know whether we've seen this slide before, but it's basically the way I look at it is rather than have a page life cycle where you have like onload, DOM load complete, and a whole bunch of other things around like how a web page loads up, you now have the ability to have like a whole entire range of pages inside your site that have a life cycle. So you install the service worker, you get this kind of install phase where you can go and download assets and install content for later use for offline. Then it's activated, and then it goes idle, and then it can respond to like your entire site can respond to operating system level events, whether it's push notifications or anything in the future coming through. And I think that's actually really powerful. And like service worker is the glue that is going to bind the rest of the future of the web together for us. But it wouldn't be without me doing a normal talk about this, where I actually do talk about APIs, because a lot of developers don't know like the capabilities of the web, right? I know we talked about them briefly, but we do have a good range of APIs which allow you to build compelling applications on the web. The way I've tried to classify this is that there are some around developer productivity. This isn't really a user benefit if that makes sense. It's about you being able to build applications more effectively and quickly. And there's a bunch of things which I'm not going to talk about, like web components will come to Safari at some point because it's in WebKit. Like web components will help you kind of componentize your application. I'm going to leave that out today, but look out for that one. It's been a long time coming. Device capabilities, and then different ways that we can think about discovery, how users can find your service and then get to your service as well. And I've got some nice demos to go through. So with regards to developer productivity, like ES 2015, basically this is the next generation JavaScript. It just makes things a lot easier for you to actually construct your applications, right? So I've destructuring. For some reason, I called it desugaring for about 2 years when I was learning about this. I don't know why. Destructuring just allows you to pass multiple arguments into the variables within one line. There's a bunch of other things. We've got classes. Promises is probably the biggest thing. If you're into service workers and doing things with service workers, you'll be using promises for everything. And that's basically allowing you to respond asynchronously in a way that isn't just kind of littered with callbacks. It's a nicer model for you for building applications. We have classes, and you can subclass some kind of intrinsics inside JavaScript as well, which is really cool. The question everyone has is, what is the developer ecosystem support, like the browser ecosystem support? It's not like completely there, but we're getting to the point now where most modern browsers support a good majority of the APIs that you want. So probably 80 or 90% of your users will be able to use promises, for instance. If you still need to polyfill out, then we have the polyfills, and you can still do that, and you can alter your build tools. But there really isn't that much of a reason why you shouldn't be using many of these newer kind of constructs inside JavaScript anymore. And they make your kind of development lifecycle a lot more effective, a lot easier, and it's easier to maintain and debug going forwards. We have CSS custom properties. I know you can't see this very well. The easiest way to say it is, I like this for kind of theming and just kind of componentization of my CSS. But basically it allows me to kind of just put variables in, so I could say like the color of my elements is pink or something, and then I could use that in multiple different places. And rather than having to update that in CSS, every time I wanted to make a change, I just update the one root variable. Allows me to kind of, basically it is just variables inside CSS. It's a nice model. It's coming through. If Jake was here, Jake Archibald, he would be talking about streams. I'm going to briefly talk about streams, why they're important at least. But the idea behind things is like service worker, you get a fetch event, the request is sent out to the network and comes back in, and then you send it back to the, you can manipulate it and then send it back to the server, but it's done in chunks. So it's like you get the fetch, comes in one, then you have to wait for it to process, and then you can send it back through. In most cases, you really want to just incrementally change the file as it streams through. So basically, you do the fetch. In your service worker, you might do some manipulation. And then as you're kind of, because it's a long chain, as you're doing that, you kind of keep manipulating it, but you keep pushing it out, so you're not blocking the browser from rendering. It is one of those things where it's a developer convenience feature, but it kind of helps the performance of your sites, especially in the context of service worker. And this is like the without streaming method. We saw like the fetch method earlier on, where you can kind of request some data from the network, then you'll get some text, you'll convert to text, and this is you trying to find some, like, if you have a 1 meg file that you have to download and you want to search for the word hello inside it, then you have to get the whole file, then search for hello, and then kind of then send the response out, which kind of basically blocks the process, especially if like hello is pretty early on. You have to download the whole file and do the stuff. And with streaming, it's a little bit more complex in the code, but the most important thing here is that you get a stream reader, you get a reader, you read through it, and then you can incrementally kind of, well, actually this one doesn't, sorry. This one is just basically, I'll actually show you the demo. No, well, I'll leave the demo because it's going to be too long. This one is, you get the stream, you get the reader, and then you can kind of, this just shows the stream reader working. So you iterate through all the bytes, and then it just like every kind of couple of hundred bytes, it logs it out, which is pretty nice. Doesn't really do anything apart from log the console. It's the next slide, which is the interesting one, is because in this case, you're basically going through, I missed a slide out, I think. Oh, no, I haven't, sorry. You're going through, the buffer includes, so you basically get chunks of text. You can search the buffer so you don't have to search the whole file, and then start to log it out. And then if you find your first result, you can cancel a request. Like cancel a reader, close it down, and get the data back out to the user as quickly as possible. It's a nice model coming through. It's not quite ready just yet in most browsers, but it's one of those ones where you should, like if you're building something in a progressive web app, you should be starting to think about it. And the interesting thing, and Jake has done this as well, but you can build your own streams. Now this demo would create a readable stream, which is a type of readable stream, unfortunately. And then it basically constructs a response. So in your service worker normally, you can make a new response and return that back to the client. But it's basically like the string of text that you would send back normally. If you wanted like an infinite loop, I don't know, you probably wouldn't want an infinite loop to do it, but like if you wanted to just kind of send an infinite stream of data, then you can't do that in Service Worker today, but with the readable stream you can, where you could say like every second output some new data, and then it pushes that to the stream. But the web page is already rendered, it just gets more and more content as it comes through. Doesn't mean the spinner kind of keeps spinning, but it's an interesting mechanism. The nicer bit now is the device capabilities. Like these are the things that most people kind of expect. Like, oh, the web can't do like I still hear this every day. The web can't do geolocation. It can, we know it can for a long time, it's been able to. It can do a lot of other things. Some things that we're working on are implicit. So like, you don't need to do any work to be able to get these things. And it's basically Chrome is saying that, hey, we're gonna make sure that when a push notification comes through, it's going to use the native push notification infrastructure, which means it gets replicated out onto your watch at this point. So Jake sent me one. He said a rude word underneath. I had to black it out a little bit. But the idea behind this is that even on your watch, you'll be able to do all the actions that you need to kind of swipe through. You can then kind of click an action, and then it'll go back to the service worker on the web page. So we're saying, like, don't always have to think about you're going to have to introduce a new API to get any of this. Like sometimes we're just doing these things because we know that we can do it, and it'll just provide a better user experience. Like I said before, there's a whole bunch of APIs coming through as well. The interesting thing as well for me is that 2016 is where we're at now. The big changes are auth and payments. They're things that are being worked on at the spec level at the moment. So like the W3C and everyone know that we need to solve these problems. Browser vendors know that we need to solve problems. Like how do you identify a user on the web effectively? I'll talk about that one today because I can. Payments is like, that's an ongoing issue, but we want to make it easy for developers to be able to streamline the payment infrastructure to use the underlying hardware, whether it's Apple Pay or whatever it is, to be able to kind of make payments effective on the web. So this is the payments API that's been proposed at the moment. I'm not going to go through it too much, but you make a payment request, and at some point you basically, the system UI would pop up, and then you would get the shipping address, and then the payment bearer, and like basically you can get all the credit card information if you need and pass it on to the payment processor at this point. The idea is like it should in theory be that simple to actually start to kind of fill out all that information to be able to get the details and make the payment on the web. We're not just there yet. I wouldn't expect this to launch for a while, but like the work is on to try and get this working at the moment. Background sync is one of the ones where I actually want to show you a demo. But the idea behind background sync is that whenever you make a web request today, if the network drops out, like you lose the network request. So if you're kind of submitting a comment or trying to make a payment, like that's the worst time for a payment to drop out at the moment is if like something happens and you can't complete. So the idea behind background sync is that you can say, do this event, or do this chunk of work or this piece of work, and then just do it. If I'm online, complete it and send it through to the network. If I'm not online and I'm offline and I don't have an internet connection, wait until I've got a network connection and then send it through. So the idea is that you can build resilience into your website by having the kind of the system take over. Do you want to see me try and demo this? Have we got time? Cool. So I'm going to press escape on this. I'm going to move. You can see my desktop again. It's good. So there's a folder in the top right called tat, which is basically an English word for rubbish, essentially. So here we go. I'm going to move. There's a great app. If you ever want to stream your screen to your device, to your PC, there's an app called Visor on the Chrome Web Store. And it basically, you connect your Android device to it and it streams the screen. So it's really good. So this is the app there. I'm going to bring the desktop. So this is like a chat client. And like you want to send a really important message to someone. Let's see if I can do it. The idea is it's an emoji-based app. I'll send hello, whatever it is. Cool. I'm sending it because I'm online, and it should go through. It's gone through. Then in my app, sorry about this. There, it's gone through there, right? That's nice. That's not using background sync. That's just normal stuff. So what I'll do is I will, you know what I'm going to do? I'm going to take my hand here. I'm going to clear out all these things because there might be secret stuff in there which I shouldn't have shown you. I'm going to go into airplane mode. So that's still working, right? That's good. Daemons. Send. So it's not sent. Right, what I'm going to do is I'm then going to go back to this screen. Here. Good. Right, and then I'm going to go airplane mode off. Hopefully I'll connect. And when I did demo this, I tested it earlier on, it did get sent through. And There we are. Cool, it's come through. All right. So that's kind of cool, right? Thank you. I think that's pretty cool because like we've been able to introduce resilience into the application. Like the site was closed down. I closed down the site and everything, and I could reconnect. So this is the thing. The important thing is that even though I reconnected through, the browser doesn't have to be open. I killed the browser off earlier on when I moved it off screen. The browser doesn't have to be open, and the task can still complete because it's sent to the service worker, and the service worker does that piece of work. So I think that's pretty powerful. Go back. Hopefully it doesn't go back to the start of the presentation. It doesn't, which is good. Credential management API, this is another good demo. So authentication is a really hard problem, right? We're not going to give you an API which identifies a user individually without their consent. But you want to be able to say, well, we've got a login system, and we've got this thing called Smart Lock in Google, at least anyway. We've got this login system, and we know the username and password. I want to be able to kind of save that and like to the system, and then have that synchronized across all my devices, but in a programmatic way, and not have to rely on Chrome to do it all the time. The credential management API, there's a blog post that's going out later today to talk about it. But the idea is that you can persist and pull out credentials. You don't actually ever see the password. It's completely opaque to you as a developer, but you can attach it to a form. You can attach it to an XML HTTP request and those types of things, and then be able to authenticate the user effectively that way. Now, the nicer demo around this is, if I go back now, new chat. Oh, so someone's on the chat app. Okay, I can close that one down, I think. Close that one down. I'm going to bring up my next demo. So this is the demo that Eiji Kitamura made on our team. And the idea is that, so I've got my phone. My phone doesn't know who this account is. I'm going to sign up as a new user. What should we say? Bob Test is the name. Test at Gmail. I hope there's no one with that name. Password, whatever. I go register. The smart lock system says, hey, you're trying to save a password. Do you actually want to save it into the store? Yeah, that's cool. I'll save that. And the username is Bob Test, right? Okay. So now if I get my application, if this works well, what should happen? What have I done? Oh, there it is, cool. So I'm going to switch accounts, or switch. Oh no, it's there, isn't it? Sorry. I'm going to click sign in. I don't have to enter it, and then there it is, Bob Test. It's just come through. You can log into your app. Well, you should be able to log into your app. There's a little bug there. Oh no, there is. So I can put my. What happened there? Did someone clap too early? But anyway, so the thing is, I've got, whatever name, fake email address. Why is he doing that? I don't know why he's done that. But the idea is, I've got that account. There must be a bug in this. There is a bug in this, because it did work earlier on. But the idea behind this is that I've got the email address and the password sent through and synchronized. We saw the Bob Test account come up. We can pull the details out and then resubmit that to the form and auto-sign the user back in straight away on the mobile device without ever having them to enter anything. It's a nice way of synchronizing devices and experience across your users' devices, at least. I'm trying to work out what to do now. I know I've run over time, but we'll keep going, if that's okay. Credential management, media stream recorder. I don't know why I keep doing this. Media stream recorder is a really nice one. We've always had the ability to, say, access the camera. So this is the camera on my device. Let me just try and get the QR code up. So we've got a streaming camera. I'm going to put that in front. There we are. I picked up the QR code that was there, which is nice. I could open the link if I want. I'm going to cancel that. I don't want to go to that one. I'm going to close that demo because we've had access to the camera for a long time. We don't have it fully on Safari just yet, but that doesn't matter too much. But the problem is we've never been able to kind of record the video and the audio directly from the camera. And in theory, if we work this out right now, we can. So I'll stop recording. Hello. Stop recording. Play.
Hello.
Cool. And you can download it as well.
Hello.
Oh, it's annoying, isn't it now?
Stop recording.
Hello. You're going through. Cool, I can close that one down as well. But it's pretty simple, right? I mean, it's a nice API. It's pretty simple. We can already get access to the camera. We get access to that media stream, and we can do whatever we want with it. And in this case, we get the media recorder. Whenever there's some data available, so like a frame comes through, we push it onto a stack or into an array, sorry. And then we just basically say, well, later on, what do we want to do with that array? Well, we want to download it, attach it to a link and pull it out. So we have the blob, we have all the data that's come through, we can attach it to a video, we can just download it straight away. You could upload it, so say you had a chat app and you wanted to do something around that, you could upload it straight to the server. It's pretty neat. That's cool. Web Bluetooth as well. Has anyone heard of Web Bluetooth? A couple of people. Well, yeah, you guys would. Cool. I am going to try and... this is a hard one to demo because I don't have the demo up, actually. I am going to leave it, unfortunately, just for now, because the demo is not there. But the idea behind this is that you can access the... Actually, you know what? I've actually got it. So I've got it here on desktop. Bring it across. Cool. So this is, it's not the great demo right now. So I've got a fake Bluetooth app, like broadcaster on this. It's a battery service, right? So if you've got a rechargeable battery, it broadcasts on a special UUID, which you basically just updates the status level on. Like heart rate monitors work really well as well. But this one, if this works, as it comes through, Nexus 6P. So my Nexus 6P is actually running the Bluetooth thing just there. If I go through, press it, connect, it should do a breakpoint. Has it done a breakpoint? Oh, this is terrible. I'm really sorry about this demo because I didn't think the screen was going to be this small on this bit. Right, I'm going to... So can anyone see the run button on the screen? There it is, sorry. Sorry about this. So there we go. So we've gone through, we requested the device of type battery service. The device comes through. We have the name of my device, Nexus 6P. We go through from there. If I go through to the next bit, it should work as well. We can connect to the service. Now we've got the service, or the server, it's called a server in this case. You can get kind of the fact that you know it's connected. The device is a Bluetooth device, and then you can start to do extra things on that. So there's different characteristics that Bluetooth devices emit and a whole bunch of other stuff. You get the characteristic, then you can start reading from it. So like that's where the heart rate monitor comes in. You read values from it every so often. The reason why I really like this is because I hate installing the Fitbit application. And I don't think you're not going to need it in the future, right? So like the idea is that you just send the user to the website, they open up the website and go from there, and then they connect it to their Bluetooth device, and then it can connect as it needs to. We had a really nice demo from one of the... So how do I get back to the other screen? There we are. Cool. That's how you do it. Like the Xiaomi fitness band, like we've got a sample for it on our GitHub repo. Works really well. Like you can just kind of pick up the number of steps that you've made and a whole bunch of other stuff. It's really nice. But that's a really nice future API that's coming through. There are actually a whole load more APIs that are coming through that I don't have time to talk about. We're still trying to work out how web USB will work. We think that we can connect to USB devices on the web, which would be good. NFC, sensor APIs, media streams, foreign fetch, an intersection observer, which is good. The one I do want to show everyone, though, is a physical web. So I have a beacon. This beacon here is emitting a URL all the time. This is the whole idea behind Discovery, is the more and more ways that we can kind of get your experience in front of users. Now the idea, if I go back, find devices, we connect to my laptop, not my laptop, my phone. So it's there, isn't it, right? So if you turn off the screen, so the Bluetooth device there, it lasts for 3 years, it's just broadcasting a URL. The theory is that what happens now is Chrome detects that there is a device that is broadcasting a URL around it, a URL, sorry. It goes, okay, cool, there's a physical web device nearby. Click on it. Go there, it launches it up. And the idea behind it is it finds the, I don't know why it's not working right now. There it is. So this is find the beacon. The beacon is broadcasting my URL. It could be your business, it could be your restaurant, it could be anything around those types of things where if you're standing in front of that in front of that experience, you just might want some extra metadata, like is it the restaurant opening times, menus, a whole bunch of other stuff. There's this company in London who have the bus stops. Now we've all got beacons in, they broadcast physical web URLs, so Chrome will pick it up. You can then go, okay, this is the bus's timetable at this place. Click on it and you open up the experience, which is my site. If you ever want to read it, it's pull.kinlan.me, which is nice. Physical web is just a nice way of doing it. It's seamless. The idea is it's seamless, it's not intrusive, it's all user opt-in, but it's simple to implement as well. You don't actually have to do anything physical to do it. So some final thoughts. I'm actually going to be really quick now. I've gone over quite a bit. We do want experiences to work across all devices. Like, if you build an experience that just works in Chrome, it's the wrong thing to do. These experiences should work absolutely everywhere. Responsive design, progressive web apps, like they can be built to work everywhere. We want everyone to focus on instant loading. Like in my head, 1 second is the absolute maximum bar to get something readable on the screen. It doesn't have to be the entire site. But if you integrate things like service worker, repeat visits can be like substantially less than that, which is quite powerful. Keep the user engaged, get them on the home screen if you think they should be on the home screen. Push notifications are a really good way of doing that. There are other ways that are going to be coming through as well. Like if the geofencing API comes through, like, you know, you'll be able to kind of re-engage with the user once they kind of enter one of the geofences that comes out. And be resilient, right? You know, make sure that your service works offline. If the user clicks on your home screen icon, like they shouldn't get the dinosaur ever at all. If you have kind of interactions where there's like a state change that happens, whether it's a payment or an order processing, then use background sync to make sure that you can complete it when the network connectivity comes through. And in my head, at the moment, I think we can definitely get to the point where we can question whether we need a native application. I think we have a big funnel from the web. We have a lot of kind of capabilities and like a good chance with progressive web applications. It's one of my big questions. Developers.google.com, if you want to stay up to date with the latest of the web platform, that's my team's doing a lot of this work. Developers.google.com/web/updates. We update this every couple of weeks with more and more articles about like the newer kind of platform features coming through. If you want to learn more about progressive web apps, g.co/progressive web apps will take you to our entry point for the guidance my team has created. Oh, sorry, do you want me to go back? I'm going to move now. Cool. Chromestatus.com. This will tell you everything that Chrome is implementing and like far-reaching future things that are going to land in dev channel, in beta channel. When things land in beta channel, that's when you really want to start to think about it. Things like the deprecations will take then 6 weeks to come through. You actively want to be looking at this site. So Chromestatus.com is a good one. And with that, I would like to thank you very much.